right. Go crooked here. Okay. Today we are going to continue on in chapter 10. So last week we introduced this concept of the mole.
Great.
And we said the mole is just a number of things. Just like if we said you have 1 dozen of anything, you would know that that's 12. If you have a mole, 1 mole,
Very good.
The number of things. Okay. Also, if you haven't turned in your homework from, Friday didn't have homework. That's right. So, I was sitting here thinking, why didn't anybody turn in homework? It's because there wasn't it on Friday. So, anyway, we just have that. Okay. But the problem becomes, how do we deal with that in the chemistry lab? Can you sit there and count out this many individual atoms or molecules?
I mean, you can, but it takes forever.
I mean, how are you going to pick out one at a time?
Oh, never mind. No.
But if you could, yes, it would take forever. Okay, you could do a quick assessment here. So, now, if you were to be able to count 1 atom every second, and you did that for a solid year without taking any breaks, to eat or sleep or anything, pull 1 atom at a time every second for a solid year.
That's a lot of seconds and a lot of time.
Now, that would get you 3.1536 times 10 to the 7.
Still not.
So,
that's for 1 solid
to
year.
continue doing this, 1 atom at a time, every second, without taking any breaks to eat, sleep, go to the bathroom, do anything else, you could get 1 mole of atoms in approximately 1.9 times 10 to the 16th years.
God.
So no, we're not going to count out each individual thing. Because
that's the legitimate reason of literally taking forever.
yeah, well, especially when you consider the entire age of the universe is about 1.4 times 10 to the 10th. So, yeah. So we needed a better way to do it. And the easiest thing, the easiest way is with something like this. It's a balance. Okay? We want to be able to use mass because that is the easiest thing to reliably measure something in the lab. Okay? So we needed some way to correlate mass and mole. But the problem is, going back to our example of just a smaller thing to conceptualize. Let's say you have a dozen pens. Okay? That's going to have a specific amount of mass. But what if you have a dozen staplers? Is that going to have the same mass?
No.
No, it's not. They're each going to have their own unique mass. So we don't have just a straight 1 mole of atoms equals this much mass. Okay? It is unique to each element. And this is where we get to use our periodic table again. So if we, for example, let's just look at argon right here. Okay. Remember when we said that we had this average atomic mass right there, 39.948? That, instead of thinking of it as AMU, like we introduced it, now we know 1 mole of argon has a mass of 39.948 grams. Okay. So that is how you should be thinking about that number now on the periodic table. Okay. If you have 1 mole of argon atoms, it has this mass.
Oh, so those numbers are the 1 mole.
Yes.
Like
all of those masses on that periodic table. If you have 1 mole of whatever it is, that's how many grams it is. Okay. So that becomes a very, very important conversion tool that we will use for the rest of the class. Okay. The concept of moles is going to stick around. It's not going away. And that conversion, using the periodic table in order to sorry, I'm looking for something that I meant to get out earlier. But yes, using the periodic table to convert between grams and moles, that is a super, super important skill. Okay. Now, just as sort of a visual here, I have 4 different metals. Okay. And each one of these blocks represents 1 mole. Okay. So if we plug in our balance over here, turn it on. So let's start with this one. Now, I bet you could probably guess what metal this is. There's a good chance this is copper just by looking at it. But if we look at that, how heavy should this be on the balance if it is copper? About 63.5 grams. Now, I've had this for a little while. It's got some dings in it, so it may not be exactly that. But when we put it on, it comes up at 63.8, which is pretty close. Okay, is 63.8 closer to anything else? No, the closest thing is going to be copper. Okay? And honestly, 0.3 of a gram, that's pretty close. Okay. Now, These other ones aren't quite so obvious, are they? But through the same method, we can figure it out. So let's look at this one. We'll put this on the balance. Comes up as 56.2. What do we think that's going to be? Yeah. That matches up with iron. Okay. Once again, it's not exactly where it needs to be. It also picks up oils from my hands. I actually had a chemistry lab once where you weren't supposed to touch any of the things that you were measuring because you would pick up the oils from your hands and throw off all of your readings. Okay, we have this one. This one weighs in 65.6. What do we think that is?
Zinc.
Okay, zinc. And then our last one. This one, keeps going back and forth, but 27 point either 2 or 3 is what it keeps going back and forth on.
Aluminum.
It's aluminum. So even though it is larger than the other ones, it has a smaller mass, it's less dense. But yeah, so this is 1 mole of those metals. Pretty straightforward. This is why we use the mole, because it's easy. You can mass out something and say this is how much I have. So today is going to be a lot of unit multipliers, dimensional analysis again. Okay. We'll go through examples. We may not take the whole time if you guys feel comfortable with it. You want to keep doing examples, we can keep doing examples. But really, today is going to be a whole lot like the previous section. Okay? You're going to be given some sort of information, and you're going to have to get another piece of information based off of this dimensional analysis. Okay? But let's go through the examples so that we can make sure everybody feels good about it. But like I said, if you felt good last Wednesday, this is going to be a lot more of the same. Okay. So let's just start with example problem 2 on page 328. So we've got chromium. It gives us information like it always does. A transition element, component of chrome plating. Chrome plating is used on metals and in steel alloys to control corrosion. Great. Calculate the mass in grams of 0.0450 moles of chromium. Once again, let's start with what we know. Okay. So we know we're dealing with that. Now, when we look at our periodic table and we find chromium, right there, number 24, we know that we have 1 mole equal to 51.9961. It'd help if I wrote it the way I said it instead of. Now, if you round it off to 52, you're going to get pretty much the right answer. It's good practice to use as much precision as you can, but if you rounded that to 52, it's going to be pretty darn close to the right answer. So now, since we know this, we can set up our two equivalencies, okay? So we can say 1 mole over 51.9961 grams, or 51.9961 grams over 1 mole. Okay? So our next thing is going to be one of these two. How do we decide which one we're going to use?
The mole of the 0.0450.
Okay, so we've got mole right there.
So our mole is the value.
So to get rid of this, we want mole right there. So we're going to use this one right here. We do 51.9961 grams in 1 mole. Our moles cancel out. We're left with grams of chromium, which is exactly what we want. So we do this. And as I'm looking at the book, they do use the value of 52 because the periodic table in the book does round that off. Oh, actually, it doesn't. Interesting. They're kind of doing some different things there. Every once in a while, the book does something that I would disagree with, but hey, whatever. Textbooks, you will find this as you go through school. Textbooks always have at least one mistake in them. Always. So hopefully you can see that it is a mistake and that it doesn't, throw you off later. But anyway, so we take this, multiply by this, okay, which if we're rounding off 52, and that'll be close enough, is 2.34 grams. Chromium. So we've got all our units either canceled out or accounted for over here. Okay. Pretty straightforward. Okay, we're doing the same thing that we did last time. We're just bringing grams into it because of the conversion factor that we have with the periodic table. Okay. Let's do another one. Let's do one of these practice problems. So if we look at, still on page 328, let's just do the aluminum. Okay. 3.57 moles of aluminum. So once again, we go to our periodic table. We know that 1 mole is equal to 26.9815 according to that periodic table. It's another thing you'll find, different periodic tables carry a different number of digits. Just kind of the way it is. Now, I've gotten to the point where I don't write down any of this. I can go straight from the periodic table into here. You'll probably get to that point pretty quick. But if you are struggling, just write things down, okay? I'll never take off points because you are writing things down to figure stuff out. All right, just make it so that I can, as long as I can figure out where your final answer is. So since we have that, our two conversion factors could be either this, got my grams there, or okay. So which one of those would we want to use? The one on the bottom, okay? Because when we put this in right here, our moles will cancel out, and we're just left with grams of aluminum. Okay. Put that into the calculator, and that ought to get us about 96.3 breaks. Pretty straightforward. Okay. Let's do a couple examples going the other direction, though. So this was moles to mass. Let's do mass to moles. So this, we'll move on to example problem 3. This will be on page 329. Calcium, fifth most abundant element on Earth, is always found combined with other elements because of its high reactivity. Okay. How many moles of calcium are in 525 grams of calcium? Once again, start with what you know. 525 grams of calcium. Go to our periodic table. We see that 1 mole, 40.078. So we can set up our.
We got a lot more than that.
So we can set up our conversion factors again. And which one do we want this time? This time we actually do want the one on the top because it has grams on the bottom, which is what we're trying to get rid of. So we bring this over here, say 1 mole on top, and 40.078 grams. Top, bottom cancel out. The units we're left with is moles of calcium. So now we do our, so we multiply across here, 525. Multiply across here, there's really nothing to multiply. 40.078. We do that division, which gives us 13.1. Bring our units, moles of calcium. Okay. So like I said, as you get more comfortable with this, you probably stop writing this. And honestly, if I'm doing it myself, I usually don't write these two. Especially if there's a 1 right there, I know that all I have to do is divide those. Also, if you have a calculator that can do, like I can do all of this and then tell my calculator to do everything on the bottom too. So I usually do it all in one step. Anyway. So. But yeah, same thing, just using the other conversion factor that we wrote because we're going the other direction. Now, does anybody want to do another example of that, or do you feel pretty good? You can do another example if you want, but if you feel good, then I'm not going to waste everyone's time. But I'm happy to do another example. Feel good? Okay. So the next thing, and this is where writing those lines that I always do, this is where this is going to be really helpful. Okay? Because when we get to example problem 4, so we've been doing mass to moles, but example problem 4 is actually mass to atoms. Mass to atoms. So let's look at what we have going on here. So gold, and it gives us some information. Gold is one of a group of metals called the coinage metals, copper, silver, and gold. Okay? Obviously called coinage metals because we make coins out of them, or at least we used to. Now it's one of them. So how many atoms of gold are in a US Eagle, a gold alloy bullion coin with a mass of 31.1 grams of gold? So we start with what we know. We know we have 31.1 grams of gold. Now we want to go from grams to atoms. Do we have any conversion factor that will go from grams to atoms in one step? No. So this is going to be a two-step solution.
We're looking grams to moles to atoms, right?
Yes. So the first thing, we need a conversion factor to go from grams to moles. So if we look at gold, 1 mole
196
is equal to
196.
196.967 grams. Okay, now I wrote it like that because I know that's how it needs to go in. Like I said, if you are having trouble figuring out which way to put it, write both of them and decide how to put it in. But, so we know that 1 mole is 196.967 grams. Now grams will cancel out. Right now, if we were to stop right there, we would have moles of gold. Okay. Now, the solution in the book does this in 2 steps. It does this, and then it does another conversion to go to atoms. Now, I like to do it this way for a couple reasons. Number one, it does it all in one step because we're going to put another conversion factor on there. And number two, when you do it all in one step, it minimizes rounding error. So if we're in moles and we need to get to atoms, what's the conversion factor? Yes. So 1 mole is equal to 6.022 times 10 to the 23rd. Okay. And in this case, we know that we need to get rid of moles, so that needs to be on the bottom. And that's going to be on the top. So we need to pull this in here. Should we keep our units? Units are important. So now, moles have been canceled out, grams have been canceled out. We're left with atoms, gold, which is exactly what the problem asks for. Okay. And so in this case, we pull out our calculator. 31.1 times Avogadro's number, technically times 1 as well. And that gives us 1.87 times 10 to the 25th. And then we're going to take this times 1, that's easy. 96.967. And according to my calculator, that should be 9.51 times 10 to the 22nd. Is that what they did in the problem? Oh, look at that. It's exactly the right thing. So that's why I like this setup. You don't have to use it. Okay? If you like the way that they do it in the book better, that's fine. Because as you can see, it got us the same answer. Okay? I just had a chemistry teacher in college that would always do it this way, and it just made sense to me, so I started doing it that way as well. But really, like we've said, we're multiplying by 1. Okay? These are the same thing. We'll just go. Of course, I forgot to bring my units. There we go. Now that looks better. Let's do another example. But let's do example problem 5 because that goes the other direction. So example problem 5 gives us a number of atoms and asks for the mass. So this time we're dealing with helium, and it gives us information like always. Helium is an unreactive noble gas often found in underground deposits mixed with methane. The mixture is separated by cooling the gaseous mixture until all but the helium has liquefied. A party balloon contains 5.5 times 10 to the 22nd atoms of helium gas. What is the mass in grams of the helium? Once again, we're going to start with what we know. That is always a good practice. Start with what you know. Okay, now in this case, can we go straight from atoms to grams? No. So we need to, in this instance, go from atoms to moles. Now we're going to use this same conversion factor, but we're going to flip it the other way around. Okay? Because if we were to put it in this way, it's not going to convert it correctly. So we flip it around. We say 1 mole, 0.022 times 10 to the 23rd atoms. Atoms, atoms, gone. So now we are in moles of helium, but that's not what the problem asked for. It asked for the mass in grams. So we go to our periodic table, and we can see that 1 mole, 4.00260. Okay. Now, we know that 1 mole has to be on the bottom. Okay. Mass in grams. Okay. So now we have that set up. Okay. We do our math. So we do 5.50 times 10 to the 22nd. Multiply that by, we'll just say 4 because that's what the book uses. You know, count that 260, and honestly, it's not going to make a huge difference. So that is going to give us 2.2 times 10 to the 23rd, divided by Avogadro's number times 1. I don't need to bring that atoms because it has been. We just put that in. And we get 0.365 grams here. And they round it up to 366. That's probably an effect of me using that extra 2. So like we said, it's a lot like last week. You're going to be taking information that you've been given and then putting it through 1 or 2 unit multipliers / dimensional analysis, whatever you want to call it, to get to the final answer. So yeah. If you want to do more practice problems together, we can. Otherwise, I will let you get started on your homework early and give you lots of time to work on it. Well, if you're ready, then I'll let you get started on some homework. And if you do have questions, if you run into anything on the homework that you're not sure about, yeah, just go ahead and ask.